this is Dr. Speranza, and today we're going to be learning how to use the empirical rule or the 68, 95, and 99.7 rule for a normal distribution. And at the end of this lecture, you'll be able to understand how to approximate the area under the normal curve using this rule. So stick around and join my students here in Barstow Community College to learn statistics with me today. Good morning and welcome to my statistics workshop, and for today we're going to be working on the normal curve. And for most students, a normal curve is an abstract concept in mathematics, but if you will understand why we're using those numbers, percentages, those partitions, it's actually really useful and it will help you understand math better. And to be able to understand the normal curve, you need to understand the language of math, just like what I've been telling you over and over and over and over again. So let's start with something that we already know, which is plotting points and creating graphs based on the frequency. So we are going to be organizing the number of teenage boys aged 10 to 18 years old who had the growth spurts at this particular age. So for 10-year-olds, we have one 10-year-old who had their growth spurt at this age. And for 14 years old, we have 9 boys aged 14 years old who had their growth spurt at this age. Alright, so we have all these frequencies. And now, let's graph it. So we're going to be graphing this using a histogram. And we already know how to graph a histogram, right? So for 10 years old, how many students do we have for 10 years old in this group? 1. So we have 1 right there. How about for our 11-year-olds? 2. So basically what we're doing is we're producing a histogram, which we already know how to produce from last week. And the reason why we're doing this because we will connect this lesson that we had last week in our lesson today, the normal curve. And why is it a normal curve? It's just a nickname that we use in statistics whenever a curve is symmetrical. So every time you are producing a graph, a histogram like this, that is producing a bell-shaped curve, we call it normal curve. So every time you hear normal in statistics, in your brain, you should be able to visualize a bell-shaped curve. But we don't call it a bell-shaped curve because we want to keep it short. So normal is the easiest way to say it. No, I'm just making that up. But in statistics, we call it the normal curve, which means we are basically producing a curve that is showing that 50% of the boys that we collected or that we surveyed are in this side of the graph, which is from 10 to 14 and a half. That's our first 50%. And the other 50% is from 14 and a half to 18 years old. So that's basically what it's showing you. So, all right, empirical rule. So we have a lot of rules in mathematics, and this is one of them. We call this the empirical rule, and basically it is a shorthand or it is a shortcut on the percentages of the distribution in a bell-shaped curve. And that is the 68, 95, and 99.7%. So this is a theorem or a statistical theorem or a statistical value that we use to approximate the percentages in a normal curve. And now let's use that in our first example. So the 68, 95, and 99.7 is associated with a normal curve. And what it means is basically it's giving you the partition or the percentages of your normal curve based on the mean and the standard deviation. And in a normal curve, the mean or the average is right here at the center. Just like what we had on the histogram a while ago, the center is at 14 and a half years old. So here, the center is right here in the middle. Alright, so what is the significance of 68, 90, 95, and 99.7? Here. This is your 68%, which means approximately the value or the area right here in a normal curve is about 68%. That's basically what that number is. So 68% of your distribution is on one standard deviation away from the mean. To the left of the mean and to the right of the mean. So if this is 68%, half of it, what is half of 68%? 34. So that means this is 34% and this is
34.
another 34%. And we're going to be using these numbers later on. So it's basically just partitioning your normal curve according to percentages. And that's for 68. And what about for 95? 95 is going to be 2 standard deviation away from the mean. So this one is 1 standard deviation away from the mean. And if we add another standard deviation away from the mean, now our area under the curve will be wider, right? Now we have more coverage in our normal curve, right? So this is going to be our 2 standard deviation away from the mean. And are we still going to have 68% in the area under the curve for this one?
Yes.
Still 68% for 2 standard deviation?
No.
No. It's going to be how much? 95. And it makes sense because if we're going to shade this region right here, do you agree that this much approximately is about 95% coverage in this bell-shaped curve?
Yeah.
Yeah, it makes sense, right? So that is 2 standard deviation away from the mean. So we're using the standard deviations to approximate the percentage of our distribution in a normal curve. So now we have 95%. 95. That is from here to here. Now, if we're going to take half of it, how much is half of 95%?
47.5.
This is 47.5 and this is
47.5.
47.5%. Alright, so are you seeing the percentages in the normal curve now?
Okay, so you were telling us half of it, since it's 95%, the 2 standards, the whole thing.
Yes, the 2 standards,
It's
the
95.
coverage is 95%.
Okay, and you say the other half, it's only 40%, 47?
47.5, because if you use your calculator, 95 divided by 2
Okay. Okay.
is half of it, and then 47.5. And if you add them up,
Okay.
right? Recap, if we're in the middle and we are using 1 standard deviation above and below the mean, the coverage is only 68%, right? And if it's 2 standard deviation, that means we're going to go wider, so the coverage on the area is also wider, and that is 95%. And if we go further, which is 3 standard deviation away from the mean, are we going to have more coverage in our area under the normal curve?
Yes.
Yes, obviously. And according to statistics, that's 99.7% coverage using your normal curve. So, now.
Yes.
And just like what we did on the 2 other percentages, the 68 and 95, if we take half of it,
49.
what is the coverage of my half right here?
49.85.
49.85%, and this much is the same. Okay, so this is now the 68%, 95%, and the 99.7%, which is basically the approximated area under the normal curve using 1 standard deviation. So we only have 3 standard deviations that we're going to be using, because if we have another one, it will go outside the range of the normal curve. Now, let's make it a little bit more descriptive and useful. Because right now, we're just seeing it as 68, 95, and 99.7. And in my case, what I'm seeing is 1, 2, 3, 4, 5, 6, 7, 8. I'm seeing 8 partitions. Are you seeing what I'm seeing? I have this, I have this, I have this, I have this, 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 this. And each of these has a corresponding area. This right here, this right here, this right here are all different areas, right? right? Do you understand why it's 34%? Does it make sense?
Because it's half.
Yes, because it's half of 68%. Now,
Oh.
what about this little piece in the normal curve? What do you think is the percentage of that piece? Is it also half of 95?
No.
No. Right? That's why I'm going to give you a better normal curve in our calculation so that you don't need to compute for this over and over again. How? Let's use the standard deviations and its partition into this. Now we have more. Now we have more area that we can work on. So this piece right here is 34%. This piece is also 34%. This piece is 13.5. This piece is 2.35%. And this tiny piece right here is 0.15%, not even 1%. Again, this is a more detailed approach on how to use the 68, 95, and 99.7% rule because now we have a better idea on the percentages of each piece in this normal curve based on the standard deviation and the mean. Again, this is 68%, this is the 95%, and this is your 99.7%. And we're going to use this in our first example. And our first example is going to be your height. Can you please convert your height in inches? So 5'7", 12 times 5, and then add 7 inches so that you will have your height in inches. So you have 67 inches. So if you're 5'4", you're 64. If you're 5 foot flat, you're 60 inches. And why do I want you to convert your height in inches? So that you will see the connection in the normal curve in our first example for today. And our example for today is this. Okay, imagine I ask every single student in Barstow Community College right now and ask them about their height in inches. So including you, plus a little bit more, this is my data set. So I collected 200, asked 200 students about their height. And I calculated the average height in my data set. And in that data set, 66 is my average height. So out of the 200 students that I asked, I computed for their mean, and it turned out to be 66 inches. And their standard deviation is 2.5 inches, which means their average difference is based from the mean. So this is our normal distribution, and this is how we write normal distribution in statistics. Make sure that you know the symbols we're using, and this is another math symbol that we use in statistics. N parentheses, the first number is the mean, and the second number is the standard deviation. All right. So this is the histogram that I created. So I collected 200 data sets, and this is their histogram. And if I'm going to draw a curve based on this histogram, does it look like a normal curve? Okay, imagine you have a blanket. And you put a blanket on top of this figure right here. Do you think it will give you a bell-shaped curve?
Yeah.
Yes, approximately, right? So this one will be looking like a symmetrical graph. Sort of. So it's not exactly a symmetrical graph, but it shows an approximated symmetrical figure, a bell-shaped curve, right? Because in this particular case, this right here is your 66 inches. That is the mean, which means if your height is below 66 inches, that means you are below average compared to the students in Barstow Community College. And if your height is above 66 inches, your height is above the average of the students in Barstow Community College. Got it? Dion, what is your height in inches?
67 inches.
67 inches. So if you're 67 inches, you're probably somewhere here. So you're above average height.
Yes, I'm not short. Sorry.
You're excited. Alicia, what is your height in inches? 63? So maybe somewhere here. So Alicia is below average. So that's basically how we're using the normal curve. So approximately, we know where the below average height is and the above average height is using our histogram. And this is what we're going to be using. So since this is looking like a symmetrical bell-shaped curve, let's use it and apply it in our normal curve. Now, the standard deviation, if you're not visualizing the standard deviation, 2.5 standard deviation, it means if you are 2.5 standard deviation above the mean, your height is probably somewhere 68.5. You will just add 2.5 to 66 so that you will see the location of your standard deviation in the normal curve. So that's basically how we use this. That is the significance of the standard deviation. And in statistics, 1 standard deviation to the left and to the right, 2 standard deviation, and then 3 standard deviation will cover our normal curve. And let's summarize this using this distribution. So in this case, a student whose height is 68.5 inches is about 1 standard deviation above the mean. So that's now. Let's use a smaller normal curve. So if this is 66 inches, this is the mean. 3 standard deviation away from the mean, we'll be able to summarize it using the standard deviation. So here we know that this is 68.5. And then to the other direction, if we're going to answer this problem, find the height that is 2 standard deviation above the mean. Do I need another standard deviation?
Yeah.
I need another one. So if we're going to answer this word problem right here, which is finding the height of a person who is 2 standard deviation above the mean, what would his height be?
71.
71. And how did you get 71?
You add 2.5.
Yeah, you just add 2.5. And now we know that if your height is 71 inches, you are 2 standard deviation above the mean. So a student whose height is 71 inches is about 2 standard deviation above the mean. That's basically what it means using the normal curve in statistics. Because in statistics, it's all about word problem and all about understanding what you are computing. Got it? So that's the description of 2 standard deviation above the mean for this normal distribution. Next, same normal distribution. We still have n equals 66 and 2.5. What is the height of this student who is 3 standard deviation below the mean? What is that height?
58 and a half.
58 and a half.
Because it's there.
58.5.
And how did you get 58.5?
It's right there.
I subtract. I had to do 1 by 1 by 1 and try that.
And that is the correct way of doing that. I know it's already there. Right? Well,
Like yesterday, I want to ask you, I'm like, how are they getting these numbers from where? Now, same.
now it's making sense?
Yes.
And we know that it's 58.5 inches, and the reason how we got that, imagine it's not there. 3 standard deviation is right here, right? Which means there are 1, 2 standard deviation to the left of the mean, right? And we know that every standard deviation is how much?
2.5.
2.5. So all you have to do is to subtract 2.5 for each and every values that you have in your distribution. So 66 minus 3 standard deviation. What is the value of our standard deviation? 2.5, right?
2.5.
So change this to 2.5 and you'll have 3 2.5s, which is 7.5, and you subtract it from 66, and that will be the height of a person that is 3 standard deviation away from the mean, 58.5 inches. And that's how we got that. So notice that in our question, it's always below the mean or above the mean, because that's basically what the normal curve can give us right now. Describing your height depending on the normal curve. What about this one? We're looking for the height of a student who is 1.5 standard deviation above the mean. How are you going to find the height of a student that is described to be 1.5 standard deviation away from the mean? How are you going to compute for that? Let me cover this because I already have it in the answer right here. Let's see how you're going to compute for that. Use the formula that we use. 66, right? Are we going to add from 66 or subtract from 66? Why are we adding?
Because it's above.
Above the mean. How much are we adding?
1.5.
1.5 what?
It's deviations.
1.5 standard deviation, right? Now that you have an equation, can you use the equation so you can compute for that height?
1.5.
You have your calculator, right? Can you enter this basic math equation so we can find the answer? What is it?
69.75.
What's this first? 1.5 times 2.5. Can you give me that value?
Is 3.75.
3.75, and then the total is,
69.75.
and that is the height of a person that is 1.5 standard deviation away from the mean.
How did you get the 1.5 when?
I know, that's what I'm confused.
How did I get the 1.5?
Yeah. 'Cause
If
it's
there's
half-
no 1.5?
Oh, because it's half of the other one.
Yes, see,
Oh,
half
but
of
wouldn't
this
that
one.
be points? Oh, I know, 1.25 or something like that.
It's half of the half.
Yeah, that is why we have this equation. Because you don't need to measure that 1.5 or that 0.5 anymore, because all you have to do is to use your equation so that you can compute for it. You know that the standard deviation is 2.5. And you're looking for 1.5 standard deviation away from the mean. So you just multiply 1.5 to your standard deviation so you can find this value right here, which is 69.75 inches.
So, okay.
Right? So if the question is, this is not part of the word. If the question is, find 2.25 standard deviation below the mean.
Do we use this
What is the height then? Yeah, figure this out. I'm looking for the height of the person who is 2.25 standard deviation below the mean. So in our normal curve, 2.25 standard deviation is, this is 1, right? And this is 2 because it's below the mean, so it's to the left of the curve. And somewhere there, right?
So you do 2,
So how am I going to set up my equation first?
1.
I will start with what? 66, and then will I plus or minus the standard deviation?
Minus.
Why am I minusing?
Because it's below.
Because it's below the mean. How much am I going to subtract from the 66 inches?
2.5
2.25 of what?
times 1.25? Oh, 2.5.
Because it's the standard deviation, right?
Oh, yeah, that's right.
Okay. This is our equation. And if we're going to use this equation, it's 66 minus 2.25 times 2.5,
Is 5.625.
5.625.
Uh-huh.
And if we continue our solution, what's 66 minus 5.625?
60.375.
60 point
375.
inches. So this person right here is here on this curve, and this is your 60.375. Does it make sense?
A little.
That if a person's height is 2.25 standard deviation below the mean, he's a short person. About 5 foot, right?
Mm-hmm.
Which makes sense because you're going further away from the normal curve. So the more you are further away from the normal curve, the more extreme your height is. So if you're really, really tall, where do you think you will be in the normal curve?
Off the chart.
Of the church, maybe somewhere here. Who's that?
The basketball team.
Very tall.
A very tall person. So think of a very tall person. This is probably where he's at. And if we're talking about Dion's height,
I'm in the middle. Above.
maybe here.
No.
So that
That's
is
my
how
IQ.
the normal curve looks like. So whenever you're working with a stats problem, always make sure that you connect with the problem, that you're understanding these numbers that you are seeing in the word problem, and they're just not numerical values that you need to compute for. Got it? It needs to always make sense.
So no matter what, if it's below, we always subtract, but with the deviation, we always do, like, say the 1.5 or the 1.5 times whatever the standard deviation is. Okay.
Yes,
cool.
because that is our benchmark in our normal curve. All these 200 students, in summary, their average height is 66 inches and their average differences is 2.5 away from the mean. That's basically what the standard deviation is. So if we're going to be using this benchmark to compute for this problem, that's how we answer it. So from the first 4 examples, we looked for the height of the student based on their standard deviation above and below the mean, right? Now, we're going to change the question into the percentages of students based on their height. For example, and again, this is Dr. Esperanza, and thank you so much for working with me with the normal curve. And you happen to like my video, please like, share, and subscribe to my channel. And I'm looking forward to seeing you again in my next lecture here in Barstow Community College. So, to answer this word problem, since it's a word problem, your answer needs to be in sentence form as well. So, 65% of the students in ECCs between 6 to